What do evolutionary AI, transparent databases, and the somewhat chaotic world of music rights have in common? I know, it sounds like the setup to a really niche joke, right? But I promise you, the answer we are unpacking today is going to completely change how you think about tracking data, managing digital ownership, and honestly, understanding human innovation itself.
Welcome to this explainer. Today, we are connecting some absolutely fascinating dots. We're diving deep into the powerful intersection of open-ended artificial intelligence algorithms, a uniquely patented database architecture designed by Kyle McLean-Smith, and modern blockchain applications. We are going to see exactly how structuring our data to mimic the divergent branches of natural evolution can solve some massive, real-world headaches in the music industry and beyond.
Okay, let's lay out our roadmap for today. First, we'll look at open-ended innovation search. Second, we'll examine the hierarchical tree database. Third, we'll explore code and runtime transparency. Fourth, we'll dive into modeling all possible paths. And finally, we will wrap up with real-world copyright and NFT integration.
Let's kick things off with Section 1, Open-Ended Innovation Search and the Fundamental Conditions for Divergent Processes.
To truly appreciate the database solution we're going to look at today, we first need to grasp this incredible insight from a 2019 machine learning tutorial about modeling endless divergent creativity. In artificial systems that try to mimic open-ended innovation, possibilities branch out exactly like a phylogeny, a family tree of evolutionary development. Think about human culture, or natural evolution, or even how new tech gets invented. An initial innovation happens, and then it just percolates. It fans out and branches as it gets customized to different situations. What you end up with is a massive divergent web that tracks the complex relationships of every single developmental event. And that leads us to a truly fascinating discovery. The researchers analyzing these open-ended systems noted that in this system, people only found things they were not seeking. Just process that for a second. It is completely counterintuitive. We're so used to thinking of algorithms as hunting for a predetermined goal, like looking for a specific optimal answer. But genuine, open-ended innovation, it often requires abandoning strict objectives altogether. The branches form because users naturally diverge based on their own distinct personal preferences. Endless innovation happens when you aren't boxed into a single destination.
Which brings us perfectly to Section 2, the hierarchical tree database, and co-locating data and functions.
Let's shift our focus to Kyle McLean-Smith's patent. He recognized early on that as software systems grow massively in scale and data volume, they become incredibly opaque. They're basically impossible for lay stakeholders to verify. To solve this, he designed an event-driven tree architecture. Instead of relying on rigid tables, the database itself is designed to grow organically. It physically resembles that expanding divergent phylogeny from the AI tutorial we were just talking about, expanding outward dynamically as new information and events arrive.
Let's walk through a mini narrative of how this database actually breathes and grows. It's an event-driven system. Step 1, the system receives an event for a new data item. Let's say it's a brand new music licensing transaction. Step 2, the system instantly instantiates a new child node within the tree structure to hold that specific data. Step 3, identifiers for this new child node and its parent node are passed to a kernel function. And finally, step 4, metadata is securely added to link them together. The database literally grows a new branch to accommodate the new reality, without bound, limited only by the hardware itself. Now, this underlying architecture builds into a surprisingly accessible user experience. Navigating this vast branching tree is remarkably simple because it uses a dotted notation. Resolving a path like root.l2.l3.song works almost exactly like reading an internet domain name. Traversing these nodes can lead a user directly to a specific song's audio file or right to the exact subtree that logs the usage and payments associated with a complex licensing agreement. It's actually designed to be readable. Moving right along to Section 3, Code and Runtime Transparency and Bridging the Developer Gap. Drawing directly from project correspondence in the MyText chat emails, we can see exactly how Smith explains the practical magic of this structure. I absolutely love this quote from him. I'll try to show how the code and runtime tree reflect each other so a developer can easily jump back and forth between the two types of expressions. By doing this, he's highlighting a major pain point in software development and actively solving it. He wants the living, running state of the database to be a perfect, easily navigatable mirror of its underlying source code. So what does this actually mean in practice for everyday users? Well, in this system, transparency means that nodes aren't just passive buckets holding numbers. They contain both data properties and active function properties, like scripts, co-located right next to each other.
For a songwriter, a distributor, or any stakeholder trying to untangle a complex web of music royalties, the environment is intrinsically auditable. The data literally explains its own rules and actions. Let's apply this massive divergence to the real world in Section 4, modeling all possible paths. Now we're going to synthesize these vast computational concepts with the absolute labyrinth that is the modern music industry. In his MyTax project correspondence, Kyle Smith brings up a really fascinating discussion on fundamental physics with the renowned computer scientist Stephen Wolfram. He makes a bold comparison between his own database project and Wolfram's famous computational search for fundamental theory of physics. Let's compare them directly to see the true scale of what we're talking about here. Stephen Wolfram is focused on fundamental physics, causal edges, and genetics, using computational rules to figure out the universe, right? Kyle Smith, on the other hand, is taking those exact same massive open-ended computational search mechanisms and applying them to model all possible paths in musical rights management. Rather than cellular physics, he's mapping out every potential branch of music derivatives, risk and royalty collections, using this transparent tree structure.
Think of a single musical innovation, a massive hit song, for example, as a colorful, open-ended fractal pattern of divergent possibilities. It doesn't just sit in a static table. It fractures. It splits into infinite derivatives, covers, samples, regional licensing paths, sync deals, and microtransactions. This transparent tree database is uniquely equipped to track every single one of those colorful, infinite branches as they naturally evolve. Which brings us to our final stop, Section 5, Copyright and NFT Integration and Real-World Blockchain Applications. Because look, if you have a transparent, path-tracking database that perfectly maps out digital rights, it naturally interfaces with modern decentralized ledgers. In his emails, Smith outlines some highly relevant real-world explorations for this architecture. He discusses collaborative pitches with MeTax, exploring potential partnerships with the UBC blockchain group, working on actual copyright NFT integration with IBM and Linux, and engaging directly with the Hyperledger Media and Entertainment Group. This tree database structure isn't just an abstract theory. It's a structural bridge. It's designed to give smart contracts and NFTs the robust, transparent, self-explanatory data architecture they desperately need to actually function reliably in the incredibly complex world of media rights. Which leaves us with this final, provocative thought. If an open-ended, transparent tree database, inspired by evolutionary search, can successfully map and track all possible paths of music rights and NFT digital ownership, what other immensely complex human systems could it untangle next? Healthcare records? Global supply chains? The possibilities, much like the tree itself, are completely open-ended. Thank you so much for joining me in this explainer. I hope you found these structured connections as genuinely fascinating as I do. Keep exploring and keep learning.